Welcome back to the lecture series in application of nanotechnology in agriculture. So, as of now, starting from the synthesis of nanomaterial to the basic characterization and formulations, we have moved to the application of nanomaterials in the plant kingdom, followed by their application in the animal kingdom. Well, while meandering through this journey of last 100 years of the evolving modern agriculture, we realize several points that the modern agriculture is an energy intensive and technology intensive process, unlike the past where the ecosystem itself took care of most of the progress. And the emerging technology which is coming in the forefront to counter the drawbacks of the previous technologies, which includes use of excess fertilizer and subsequent water pollution and soil pollution, are now being countered by the use of precision agriculture. So, in next few lectures we will discuss some of the other technologies which are under the spotlight in order to repair the damages which has occurred due to the last 100 years use of excess fertilizers and industrial pollutants which have damaged or which has kind of disbalanced the ecosystem of our water bodies. So, one of the challenging problem is the need for quality water, both for drinking purpose, agricultural purpose, animal feeding purpose, as well as several other applications. So, water purification is one. Second is sewage disposal. If you walk through the cities, you will see, like if you walk through Delhi, Delhi has an open sewer system. There is a big drain or a nala, you can call it, which is rolling through the city and kind of carries most of the waste. But then this waste is dumped into a river. So, that needs to be processed that way, because if you keep on dumping the stuff on the river, what will happen is that in the river you will have islands which will be formed all over, and eventually the river will shift its course and that may lead to flood. And not only that, the river may eventually die. So, how we really can handle organic waste? So, there are two emerging aspects of what needs to be addressed. So, one aspect what needs to be addressed is cleaning of water, because this has a direct impact on agriculture and food production. Okay. For agriculture, industrial, you see every kind of water you are purifying, you have to realize there is a level up to which you needed to go depending on the requirement and drinking. Though we know that the other option is cleaning of water, second is desalination of water. This is what they do in places like Dubai and other places where they have huge desalination plants where they are continuously desalinating the water in order to meet the requirements. Similarly, if you go to Israel, they have some of these units of water cleaning plants all across the country, taking care of much of the need for fresh water. Okay, so desalination of water, this is from ocean and seas. Simultaneously, there is another area which needs tremendous attention, is garbage or organic waste disposal, and sometime even converting them to useful materials. These are some of the pertinent problems what civilization needs to address at this juncture. Post-industrial revolution, if we look at the journey of mankind, say for example, if I take the example of Kanpur, Kanpur was known for its leather industry. Now the problem is that leather industry consumes a lot of water, which is not an issue. Water could be made available, but then from the tanneries, the polluted water is dumped in the Ganges, was dumped into the Ganges. Now think of it, a tannery water coming out, just as a case study if you look at it. So here you are by the outskirts of the city of the tanneries. Now this water is getting into your major water body of the country, which is the river, okay, tannery waste. Now you are basically contaminating the river. Now the future lies, if somewhere or other we have created an intervention here, we process this waste, so there is a need for now introducing some kind of innovation, intervention, design, and ensuring that yes, indeed, the water goes there, but it is no more a way filled with all sorts of harmful chemicals. So if you look around your city, you will see many such situations where we really need to figure out how to get around it. Similarly, the other thing which is very critical is the human waste, how to handle human waste. So when you talk about garbage and organic waste, this includes the human waste. So if you look at some of these design of, if you travel in the train, you will come across that there are these green toilets, what those are essentially, or you will even come across in some of these high altitude places like Ladakh, Leh. If you travel through, you will see for the defense personnel they have made these green toilets. So the idea is fairly simple, which this was one of the technologies which has been developed by Defense Research Development Organization of Government of India. What they did is, so they know the feces matter. So there are microbes. So the way it works is something like this. You have human waste, this, and there are microbes which work on them. And these microbes, over a period of time, given the right set of relative humidity and temperature, in a right set of time, they will convert this human waste into water and some form of carbon. Much of these carbons are again taken up by the microbes. Now, these microbes, what they are doing, they are either acting, they have some specific enzymatic action which ensures to take care of these kind of waste. Okay. Now, this enzymatic action could be further fine-tuned by factors what we have studied in the course. This is one approach where there is lot of efforts which are being made to see how the microbial growth could be further optimized, could be further strengthened by using nanomaterials, because most of these microbes are very, very well equipped and evolutionarily much more strong to handle these kind of small particles. So, in terms of these two, there is another aspect. What I wanted to introduce today is the need for multifunctional sustainable material. So, what does that mean? Multifunctional sustainable green material. Okay. So, there are 2-3 words here. There's a word called multifunctional, a word called sustainable, there is a word called green. Okay. Now, when we talk about nanomaterials, so if we go back and if you look the kind of nanomaterials we have dealt with, let's take one example where, let's see, we have chitosan, we have triclosan, we have iron oxide, mesoporous silica, polylactide, D-lactide, albumin dextran, okay, zinc oxide, titanium oxide. Look at the range, like, and this story can go on and on. If we go further up into our previous lectures, iron, zinc oxide, carbon nanotube, copper oxide, iron oxide, molybdenum, manganese, cerium oxide, calcium carbonate, magnesium, further carbon nanoanions, iron pyrite, cerium oxide, water soluble carbon nanotubes, silver. So, this list can go on and on. What I wanted to highlight is not that huge list, but an emerging concept. Say for example, one material, say X, this is X, say X nanomaterial. What is desired of it when you talk about? So, first thing, this material should be easily degradable, or if it is not that, or at least it should be environmentally benign. Okay, easily degradable or environmental benign. Second, the components of it. So when we talk about degradability, so the elemental component are easily or safely, to be precise, acceptable or compatible with the living systems. Okay. Further, if these are the concerns of environmental aspects or ecological aspects, then there is another side, environmental and ecological. We want these kind of material to have a multifunctionality. Say for example, a same material could be used for, say, agriculture, so same material could be used in a different form for, say, energy. So same material could be used for waste management. Same could be used for, say, water purification, and if to stretch it further, same could be used for, say, electronics. So what is needed is, though there is a lot of research on multiple nanomaterials, one of the ideas which is emerging is multifunctional, sustainable, green materials. So in the next class, we will continue from here how the world of nanomaterial is going to shape up in last 5 to 10 decades to come. Thank you.